Okay, so coming back on and thinking about this random walk simulation, we've seen that it's hard to do this by hand. It takes a lot of time, and so it's hard to do by hand. And what would be really nice here would be if the computer can do this for us. And so let's consider how to do this. It's a great class of problem for computer simulation. Now this is a random process. Sometimes it's called a stochastic process, and this is used in physics research, and Monte Carlo simulations are pretty much this sort of thing where random numbers are used to help predict how systems will behave. But that's something you can look up if you're interested. Um, right. So for the computer simulation, what we need is the ability, we need to generate lots of random numbers. I'm going to say we want them between 0 and 1. So 0.7692 or whatever. Lots of random numbers in this range between 0 and 1. And if we have lots of random numbers, then we can make, we need to be able to decide if we move left, right, or even stay put. Now, I was flipping a coin before, so there wasn't an option to stay put. It was just a 50% chance of moving left, 50% chance of moving right. But let's say we wanted to have, e.g., a 30% chance to move left and a 30% chance to move right. Now, what we can do here is to have, well, the way I think about it is to just draw a little graph. And what we're going to have here is this graph. Let's say our number between 0 and 1, let's call it R for our random number. And I'm probably going to get these shadings wrong, but let's say this is 30% here. And this is 30%, I'll shade it slightly differently. 30% here, so this is 30% here. So 30% of the top is to move right, 30% at the bottom is to move left. And we need some sort of logic. Now, I'm going to write this out as you might do it in C. So if R is less than 0.3, now I hope you agree that if the number R is between 0 and 1 and it's random, then the chance of it being less than 0.3 is 30%. So if R is less than 0.3, we could have a variable x to represent the position. We could say x is equal to x minus 1. We could use x minus minus. And then if we use an else if, we can say if R is less than 0.6. So if it's less than 0.3, we're in this region here. But if that's not true, else if R is less than 0.6, then it must be in this second region above it. So in that case we can say x is equal to x plus 1. And then we're pretty much done, because there's another 40% up here. Actually, this shows how rubbish my drawing is. That this should be 40% do nothing. But we don't really need to put that in as part of the if statement, because we do nothing, we don't change the value of x. So if we can generate a random number, then we can make some decision about whether we move left, or whether we move right, or whether we stay in the same place. Now, as we do that, we need to store data. So we need to store the information. And the natural way to do that is with arrays. So we could have an array which is x position. And in C we'd write this like this. And we could also have an array which is x position square, or x position squared. And again, that's 100. And that means that if we say have 100 steps, then we can store in this array here the position after each step, and in this array here. Well, exactly, we're not really storing the position. What we're going to do is each time we do a walk, we're going to add to x position of whatever step it is, we're going to add to it the current position, so that x position at each step becomes a sort of running total. So for example, x position 2, if you have a look at the table on the top left up here, then x position 2 would be the array which contains all the information for walks, or adds up the sum. So first of all we'd be adding -2 to it, we'd be adding another -2 to it, then a 0 to it, then a +2, then a 0 to it. And then similarly for x position squared, we'd be going down that row, adding -2 squared, which is 4, adding -2 squared, which is 4, +2 squared, which is 4. The zeros would of course just give us 0 we're adding to it. So what this means is we can do lots and lots of walks and save a running total of the total at each step of the x position and the x position squared, and then when we've finished all our walks, what we can do is take the mean. Now, I want to sketch out here on the right hand side a rough idea for a computer program to do this. So first of all, you need to set up your variables, of course, and we're certainly going to want to have things like x for your position and r for your random number, and you might want to have p for the probability of moving, and you want to have these arrays we've just been talking about. Now if in C you say x position 100 equals, and then open curly brackets and close curly brackets, segment colon, what it means is that all of the different numbers you're generating are set to 0 at the beginning. So if you set them all to 0, then that means we can just go into a loop and start adding numbers, and we know that to begin with the thing was 0. So first part of the program is to set up the variables. Now, of course, in here as well we'll need a loop counter. I'm going to call it one walk and the other one step. So what we need to have next is a loop, and let's say this is a loop where walk is going to go from 0 to 999. Let's say we're going to do 1,000 steps. At the beginning of each walk, it's important, remember, to set x to be equal to 0. Then we're going to have another loop where step goes from 0 to 99. And in each loop, the first thing you do is you need to decide if we go left or right, or even stay in the same place. And we've talked about that over here in the middle of the middle column. And then we need to add to x and x squared arrays. So you might do something like x position plus, x position, we have to put the step number in, of course, plus equals x, and we might have x position squared, the step number, plus equals x times x for x squared. And that's all we need to do really in the loop as we step through. So we have an outer loop here which goes through all the different walks, and each individual walk is in this loop inside it where we go through steps from 0 to 99. Finally, when we've done all that, what we'll want is a loop. Now again, this is going to be for step going from 0 to 99. And in this step you want to print out, probably best to print to a file here. And what you want to print out is going to be the value of step. Well, actually, I would print step plus 1, because although we call it step 0, it's actually the first step, and step 2 is step, then the numbers 1 when we get to in step is actually the second step. So I would do step 1, step plus 1 here. And then the next thing we want is the average x, so that's going to be x position for step divided by 1,000, because we've got 1,000 different walks. And then we want x position squared for the step and again that's divided by 1,000. So I haven't put this print statement into a proper format. You probably want to print it to a file, but those are the key things you want to print out. You want to print out the step, the average position, which is your sum which you've added up in this loop above, divided by 1,000, and then the sum of all the squares again, divided by 1,000 also. Now when you've done that, what you can do is make plots like the plots on the left of the average x position and the average of the squared position as a function of step. So I should of course have labeled these axes on the horizontal axis as step here and step here, and it would be good to put a title on them, but I don't really have space here. One final thing I want to make the point, I'm saying here that step should go from 0 to 99, and that's because here when we set up an array like this with 100 variables in C, the first member of the array is 0, the next member is 1, and so forth until we get to member 99, and we don't have a member 100 because between 0 and 99 we actually have 100. And just what I suggest is good to do for the loop here, if you're using C, then if we say for step is equal to 0, step is less than 100, and step plus plus. And what that will do is that will go around 100 loops with step going from 0 to 99, which is exactly what you want. The other thing is step should be an integer because it's going into the index of an array. So if we have, say, x pos of 2, for example, then the index of the array is 2. So whenever you have an index, that really should be an integer, or the computer will get horribly confused. Okay, so I hope that is helpful in terms of seeing how to put together a random walks simulation on a computer.